Hello everyone, this session focuses on some of the types of calculations that crop up on paper 1. The first question is using Avogadro's constant to calculate the number of atoms in 1 gram of argon. Avogadro's constant simply means that there is 6.02 times 10 to the power of 23 number of particles of any substance in 1 mole of that substance. In order to calculate the number of atoms, you divide the weight of the sample in grams by the relative atomic mass of the substance and then multiply by Avogadro's constant. We use the every method, and the equation, like I just said, is the amount equals the mass divided by the relative atomic mass. The values for our variables: amount is what we're calculating. The value of mass from the question, as you can see I've underlined, is 1 gram, and the atomic mass of argon has been done for you, and that is 40. The second E is for equation, where we substitute the values in for our variables. So amount equals 1 divided by 40 times by Avogadro's constant. And then always go ahead at this point and calculate anything that's in brackets or any fractions. So pop that into my calculator. 1 divided by 40 equals 0.025 times 6.02. Remember to put your brackets in your calculator around the constant, otherwise it will do the multiplication first. And then finally, once you've put that into your calculator, go ahead and write the answer where they've provided the space, making sure that if they do ask for any units, you include those as well. So in this case, it's 0.1505 times 10 raised to the power of 22. And it goes down 1 power because we're multiplying by a number that's less than 1. The second type of question is to calculate either the number of moles, mass, or MR, using the equation that we've taught you, which is mass equals moles times MR. So start off by bugging the question, which means you use the B to box off the command, and in this case it's asking us to calculate the number of moles. The U stands for underline any of the other important information, and in the question it tells us that a bag of fertiliser contains 14.52 kilograms of ammonium nitrate, which will need converting because we calculate mass in grams, and it's given us the relative formula mass for ammonium nitrate, which is 80, so we don't need to work that out. Whenever you're doing a question like this, always use the every method, which we have taught you to use throughout Key Stage 4. So first off, start by writing in the equation mass equals moles times MR. The value of our mass is 14.52 multiplied by 1,000 to convert it to grams, so that becomes 14,520 grams. The moles we're calculating, and the MR has been done for us, which is 80. Right, we then go on and rewrite the equation with the substitution. So we have 14,520 equals moles times 80. In order to make moles the subject of the equation, we can simply divide 80 by 80, hence cancelling that out on that side, and what we do to one side we have to do to the other. And so therefore when we put that into our calculator, we get an answer of 181.5. Now the question says give your answer in standard form to 2 significant figures. So we need to rewrite this with just two significant figures, and so that means if it's in standard form, therefore it's got to be times 10 to the power of. So 181.5 in standard form to two significant figures equals 1.8 times 10 to the power of 2. You can see that we've simply moved the decimal place back 2 places for our two significant places and rounded off. Question 3 is an example of calculating reacting masses. And so I've included the written method as a reminder, and then another example following the one I'm going to do on the next slide, which again you can look at your own leisure. As with all questions, go ahead and bug the question so you can find out all the information that you need to carry out this kind of calculation. So first of all, we can see that it's asking us, we're going to box off the command which is asking us to calculate the mass of sulfur hexafluoride. And then other important information, it gives us the value for fluorine, the amount of fluorine that's reacted with excess sulfur, 0.950 grams. And then we have the balanced equation at the top, and then we have the MR of the element and the compounds involved. So the first step in any calculation like this is to write out the balanced equation, and I'm just going to include the relevant parts for this calculation, which is the 3F to SF6. Arrow SF6. The second step then is to write out the MR of the substances involved. In this case, the MR of F2 is 38, and for sulfur hexafluoride is 146. We then, in step 3, scale up by the coefficient in the equation. So in terms of our fluorine, we've got 3 of those. So it would be 3 times 38, which equals 114. And of course, we've only got 1 molecule of sulfur hexafluoride, so it remains 146. Step 4 is to find the mass of the product for 1 gram. In this case, the number of molecules in 1 gram is 146 divided by 114, and if we go ahead and work that out, it is 1.28. Step 5, then we need to scale up for the mass of the fluorine. So it's 1.28 times 0.95, which gives us 1.21666 recurring. Now remember, the question asks us to give your answer in 3 significant figures. So we need to round up and down until we get down to our 3 significant figures. So the answer would be 1.22 grams. This second example of reacting masses is exactly the same method I used in the previous one. So first of all, you write out the balanced equation, and in this case it's 2Mg plus O2 arrow 2MgO. Step 2, we add the relative formula masses and the units. So we've got 24 grams of magnesium, and that comes from magnesium's mass of 12. And then step 3, multiply by the coefficients in the balanced equation. So it's 2 times 24 and 2 times MgO, or 2 times 40. Step 4, cross multiply for 1 gram. And so this is where we go back to our original equation in question 1 and 2. And it's mass divided by MR. And so 80 divided by 48 equals 1.66 grams. Step 5, we scale up to the mass in the question. And so it's 6 times 1.66, which equals 10 grams. Finally, another calculation that sometimes crops up is empirical formula. And all it is the simplest whole number ratio of atoms in the compounds involved in the formula for that compound. In this case, a compound in a copper ore has the following percentage of by mass of copper, iron and sulfur. So effectively what you're doing is finding out what is the formula of this compound from the information that they've given you. Looking at the question, it's giving us the percentages, copper, iron and sulfur, and it's then given us the atomic masses, but notice it's given them in the opposite order, and that's important because it could cause you to do a mistake further down in the question, so it's worth noting any little things like that. Now, in order to calculate the formula or the empirical formula, step one is to calculate the mole of each of the substances involved. So start off by putting in your columns of elements involved. In this case, we've got 3, so I need 3 columns. And I'm going to do it in the same order as the top part of the question. So I'm going to start off with my copper calculations here, then iron, and then sulfur. So step 1, I need to calculate the mole for each of those, which is, of course, the mass divided by the MR. So for copper, it would be, in this case, 55.6 divided by 63.5, which is our relative atomic mass here. And that comes to 876, sorry. Then I'll do the same for iron, and in this case it's going to be 16.4 divided by the relative atomic mass of iron, which is 56. And in the calculator that comes to 0.293. And then finally the same for sulfur, which is 28 divided by 32, and that comes to 0.878. Step 2 is now that we look at our lowest figure and divide the other values by it to work out the ratio. And so if we just have a look now, our lowest figure is 0.293, and 0.293 will divide into 0.78, rough about 3 times. So step 3 then is where we write in our ratios. So really, like I said, you've got about 3:1:3. And then finally, step 4, we factor in the ratio in the formula. So, and then finally, we factor this ratio into the formula. 3 times copper, 3 times copper